In this video, we'll be covering another example of the mean value theorem. Again, one more time, the mean value theorem states that if the function is continuous on the closed interval, differentiable on the open interval, then we will have a instantaneous slope at a given point equaling to the average slope between the 2 points given. So, for this example, we're going to go ahead and start off by looking at the function one more time, x squared divided by 3, which is the same thing as the cube root of x squared. Given that this is the same function as a cube root function, but it's got a little extra piece where it's always going to be a positive value. So the cube root function looks something like this. So the cube root function that's squared will look a little something like this. It's not perfectly edged, but it's going to be, again, a little bit larger at any given point. Now, with that being dealt with, we know that this is going to be continuous, then, on all values from -1 to 8. Again, continuity just says I have to be able to put my pencil down and draw the entire graph without picking it up. And that, sure enough, is continuous. Next, if I take the derivative of this function, you'll notice I get 2/3 x to the -1/3 by subtracting 1 from this power. This will provide me with something that looks more like this, 2 divided by 3, the cube root of x. Now, if you look at this one, there is a single location where this derivative is not defined. And again, that means that the derivative is going to have a problem. It means that the original function is not actually differentiable on the entire interval from -infinity to infinity, which actually, if you'll notice, its domain on this function is x cannot be equal to 0. You'll notice that right there. If I try to plug in 0 to the derivative function, then this thing fails. This tells me that my actual function, which is x to the power of 2/3, is not differentiable at x equals 0. Again, because the derivative function is undefined at 0, and again, the derivative function is undefined at 0, that means that the original function is not differentiable at 0. This leads me to state that because its continuity is from -1 to 8, but its differentiability is not from -1 to 8, then we cannot apply the mean value theorem. Again, we must have those two circumstances to first be able to apply it. Now, if this question removed that point, meaning, I'm going to modify this question here, if instead it asked me to find on the interval from 0 to 8 the value such that satisfies the MVT of 2/3, this would actually work. And the reason why this would work is because, one more time, f of x is continuous on the closed interval from 0 to 8 without any issues. And then the derivative f of x is equal to, one more time, 2 divided by 3 cube roots of x. I can't plug in 0 to this, but that means that with this domain x not equaling to 0, I can imply that the original function is differentiable everywhere except 0, which means that it's differentiable on the open interval 0 to 8. With that being done, that tells me I should be able to find a value between 0 and 8. That means that the average slope between 0 and 8 will be equal to the instantaneous slope at one given point. So that means that this function right here, 2 divided by 3 cube roots of x, should be equal to, in some form or another, me plugging in 0 and 8 to this function, meaning 8 to the 2/3 power, minus 0 to the 2/3 power, divided by 8 minus 0. Again, this is nothing more than f of b minus f of a divided by b minus a. This tells me that I'm going to have 8 in a cube root, which is 2, to the power of 2, which is 4, so 4 over 8, which is 1/2. And then I will simply solve this equation. 2 divided by 3 square roots of x equals to 1/2. I will go ahead and multiply everything by 6 cube root of x. In doing so, it will allow me to eliminate all fractions. Again, 6 cube root of x on top of both sides of this equation. Over here, the cube roots of x will cancel out. The 6 and the 3 will cancel out, leaving me with a 2. So I have 2 times 2 is 4. Over here, the 6 and the 2 will cancel out, leaving me with a 3. So I have 3 cube roots of x over here. I'll divide by 3, and I will cube both sides. This will provide me with x equals 4 over 3 cubed as the value that will work. Now, can we be absolutely certain that this is between 0 and 8? Well, 4/3 is approximately 1 and some change. If I cube that, it's going to get closer and closer to 1. So this value should work being between 0 and 8.